Welcome to the PhysicsPlace, the place to learn about physics, and in this video I'm going to tell you how you can calculate work. And before we go there, I will first explain what work is. For that, I will use this example. We have a truck going with a constant velocity, and when a truck is going with a constant velocity, there are still frictions. So for instance, the tires have a friction on the road and they are going backwards, and there's also air resistance going backwards. So to cancel these out, the engine needs to have a constant force forward. So to go with a constant speed, you need a constant force forward. That's on Earth because of frictions. On space you don't have this problem because on space there is no road, there's no air, so then if you go with a constant speed you don't need an actual force, but on Earth you do. And because you need an extra force, this engine needs to work. So it needs to put out a sort of work to cancel these different resistances and these different frictions. So to travel with a constant velocity on Earth, you need a constant force. And therefore, this engine will have a work, and we can calculate the work. The work we can calculate with the force and the distance. So the work is either in Newton meters or in joule, and it's a form of energy, therefore it's also in joule. So you can always also calculate work to energy, because work is a form of energy. F, the force of an object, is in newtons, and the d is the distance in meters. So if you want to travel a certain distance and you need a certain force for that, then you will need to put out a certain work. So if you multiply those two, then you can calculate the work it needs. And of course, if the distance will become larger, then you will need more energy, more work to travel that distance. And of course, also when the frictions go up, then you need also more work. And you can imagine if you are walking and there's a lot of wind blowing in your direction, then you need more force to walk, so it will cost you more work to walk the same distance. Also, it will cost you more work if the distance becomes larger. So an example, get a piece of paper, a pen and a calculator and try this for yourself. We have a train who needs a constant force of 2.4 kilonewtons to cover a distance of 25 kilometers. Calculate the work in megajoules. So mega is a million joules. So we have already the force, which is 2.4 kilonewtons. We have to transform it to convert it to newtons, so multiply it by 1000, so 2400 newtons. We have the distance in kilometers, also has to be in meters, so multiply by 1000. And now we can calculate the work with this equation, and we have to multiply the two. So we multiply the force with distance, and then we have this number, 60 million joules, or Newton meters. You can use either of these two, they're both correct, they both are the unit of work. Of course, it needs to be in megajoules, so we have to divide by a million, and then we have 60 megajoules. Of course, that's the same as meganewton meters. But in this case, we wanted megajoules, so that's why I put megajoules here. So 60 megajoules is the amount of work the train needs to cover this distance when having this force against it. Another example, calculate how high you can lift this brick with a mass of 1.5 kilogram if your work will be 176 Newton meters. So to calculate the height of this brick, we need to have the force and we need to have the height. Well, the height we have to calculate, we already have the work, but we need the force and we only got a mass. So we first have to calculate the force with this mass. So the force is the mass multiplied by the acceleration due to gravity, which is 9.8. So 1.5 kilograms multiplied by 9.8 is a force of 14.7 newtons. So you will use a constant force of 14.7 newtons to lift this brick. You know the amount of work you put into it, so you can calculate how high you have lifted the brick. So the work is 176 Newton meters or joules. This is the equation, and we need to calculate the distance. So we have to divide the work by the force. So it will look like this. 176 divided by 14.6 equals 12 meters. So that's the height that you have lifted the brick when you use this amount of work. Of course, if you want to lift it higher, then you need more work. And if you want to lift it lower, then you don't need this much work. Final example. When driving for 27 minutes with a constant speed, the engine produces a force of 4.7 kilonewtons. The work required is 228 meganewton meters or megajoule. Calculate the speed of the truck in kilometers per hour. So we have to calculate the speed. Well, first let's see what the information is that we got. We already have the time, 27 minutes multiplied by 60 is 1620 seconds. We have the force, which is 4,700 newtons, and we have already the work. The work is 228 million newton meters or joules. And we have to calculate the speed, and therefore we need this equation. So to calculate the speed, we have to divide the distance by the time. We already have the time, so that's good, but now we also need the distance. We don't have the distance yet, but if we look at this equation, there's a distance here, there's a force here, which we already have, and there is a work here, which we have. So we can use this equation to calculate the distance, and then we can use this equation to calculate the speed, and then we have to go to kilometers per hour. So first we will use this one. We have to divide the work by the force to calculate the distance, so it looks like this. Put in the correct numbers, and we have a distance of 48,511 meters. We can divide it by the time, so we use this equation, we divide it by the time, and then we have a speed of 30 meters per second. Then we have to multiply by 3.6, so then we have a speed of 108 kilometers per hour. So that's how we solved this example. I hope you now know what work is and how you can calculate with it. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.